Hi everyone, Dr. Mike here. In this video, we're going to have a look at an overview of the endocrine system. So the endocrine system is a collection of cells and glands that produce and release hormones. Now, hormones are just chemicals that jump into the bloodstream and can have their effect in quite distant areas of the body, at least distant in comparison to the tissues that produce and release them. This is quite different to the nervous system, which also is a communication system that controls physiological activity like the endocrine system, but the nervous system is fast, it's direct, and it's short-acting. Now, the endocrine system is slow, it's indirect, and it's quite long-acting. And so that's some of the differences, even though they're both communication networks that control physiological activity. Now, the cells or glands that produce and release these hormones, that's what we're going to have a look at today. And we're going to have a look at some of the names of those hormones and, generally speaking, what they do in the body. So to begin, we should start at the top and move our way down. Now, the top obviously going to be our brain. There's a really important tissue in our brain or endocrine gland called the hypothalamus. The hypothalamus sits at the base of our brain underneath the thalamus. That's why it's called hypothalamus. And I've drawn it up here. This is the hypothalamus. You can see there's an extension of the hypothalamus that has two parts. This is called the pituitary gland, and the two parts are the lobes. So you've got an anterior lobe and a posterior lobe of the pituitary gland. Now, simply what happens is the hypothalamus you can think of as the master regulator or control center for all these endocrine tissues in the body, or at least most of them. What the hypothalamus does is it produces and releases a number of important hormones. These hormones include thyrotropin releasing hormone, corticotropin releasing hormone, growth hormone releasing hormone, prolactin releasing hormone, and gonadotropin releasing hormone. Big names, but this is what happens. Predominantly, the hypothalamus will produce and release these hormones, and they'll travel through this blood supply that connects the hypothalamus to the anterior lobe of the pituitary gland. Then, as it moves through, it stimulates hormones in the anterior pituitary gland to be produced and released. Thyrotropin releasing hormone stimulates the release of thyroid stimulating hormone. And what that does is it travels to the thyroid. Now, the thyroid is this gland, endocrine gland, that hugs the front of the trachea. And what the thyroid does is it produces thyroid hormone. And the thyroid hormone is T3 and T4. T3 is triiodothyronine and T4 is thyroxine. Predominantly, T4 ends up turning into T3 anyway. And the activity or function of these thyroid hormones is to undergo certain metabolic processes, so metabolism. It allows for appropriate development, especially embryological development, and also stimulates catecholamine release. Catecholamines are like noradrenaline and adrenaline, or norepinephrine and epinephrine. So that's the thyroid hormones and the thyroid function. Started with the hypothalamus with thyrotropin releasing hormone, moved to the anterior pituitary where it stimulated thyroid stimulating hormone. That jumped into the bloodstream, moved to the thyroid to release these hormones. When these hormones are released and their level starts to go up, they actually go back to the hypothalamus and have a inhibitory effect. This is called negative feedback. If their levels are low, that gets released. If their levels are high, that gets inhibited. So this is a feedback mechanism to maintain homeostasis. The second hormone that the hypothalamus releases here is corticotropin releasing hormone. That travels down, stimulates the release of adrenocorticotropic hormone. Adreno tells you adrenal gland. This is the little gland or hat that sits on top of the kidneys. And so what the adrenal glands do, let's have a look. The adrenal gland, interestingly, has a little shell on the outside called the cortex, and then the deep inside called the medulla. Adrenocorticotropic hormone goes to the cortex, so the outer shell. So if we have a look at the cortex, the hormones that are released after adrenocorticotropic hormone stimulates it includes that of cortisol, aldosterone, and androgens. What cortisol does, first of all, is it increases blood glucose levels. Why? Because cortisol is released in times of stress. So when we're stressed, we need energy. Energy comes in the form of glucose. Cortisol increases that glucose availability in the blood. It also suppresses the immune system as well. Aldosterone, what does aldosterone do? Aldosterone increases the amount of sodium that's reabsorbed in the body. Why would we want more sodium to be reabsorbed? What scenario here? Well, sodium, wherever it goes, water follows. So if we're dehydrated or our blood volume is low, aldosterone can be released. It tells the sodium, hey, don't leave us at the kidneys. Jump into the bloodstream, water will jump back into the bloodstream, and our blood volume will go up. If our blood volume goes up, it means our blood pressure goes up. So aldosterone can be released when blood pressure is also low. What about androgens? Let's move this down a little bit. Androgens are simply male sex hormones, like testosterone, for example. So androgens are just male sex hormones. And they have a multitude of masculinizing effects. So that's the cortex. There's the medulla, the deep inside of the adrenal gland. And the main thing you need to remember here is the release of noradrenaline and adrenaline, which again, like I said, is epinephrine and norepinephrine, or norepinephrine and epinephrine. What do? Well, they get released, or they stimulate fight or flight. That's our stress response. So again, cortisol is released in stress, noradrenaline and adrenaline are released in stress. We want to increase our blood pressure and blood volume in times of stress. So the adrenal gland really is stimulated in times of stress. Growth hormone. Growth hormone, releasing hormone from the hypothalamus, releases growth hormone from the anterior pituitary, jumps into the bloodstream, and tells all these different tissues of the body to grow and develop. So growth hormone, unsurprisingly, tells our body to grow, undergoing metabolism. Growth hormone stimulates, increases growth. So this includes things like protein synthesis, as an example. What about prolactin? Prolactin is released from the anterior pituitary gland. Pro meaning for, lactin, lactation, the production of milk. Prolactin is released to produce milk. Now, it's not milk ejection. That's going to be oxytocin, which I'll talk about in a second, but milk production. What about the gonadotropins? Well, the gonadotropins travel to the gonads. For females, it's the ovaries. For the males, it's the testes. And they promote the reproductive cycle. So the gonadotropins, which are luteinizing hormone and follicle stimulating hormone, luteinizing hormone and follicle stimulating hormone, will travel both to the ovaries and for males to the testes. And for the males, the outcome is it increases testosterone and increases sperm production. The outcome in females is it increases estrogen, increases progesterone, stimulates ovulation, and prepares the uterine lining, the uterus, for implantation. So both of these, male and female, is going to be promoting the reproductive cycles, their respective reproductive cycles. Posterior pituitary gland. So we've gone through the hypothalamus, the anterior pituitary gland, and some of the other distant tissues that are affected by these hormones. The posterior pituitary gland releases oxytocin. And it does it not because the hypothalamus releases hormones, but because the hypothalamus sends a nervous signal to the posterior. So a blood supply for the anterior, nervous signal for the posterior. Oxytocin increases milk ejection and uterine contractions. So this is important because Oxytocin stimulates the smooth muscle to contract and push. So for the breast, it's going to release milk, and for the uterus, push bub out. That's oxytocin. It's also known as a pro-relationship hormone. It strengthens the bonds of both positive and negative relationships. The other hormone produced by the posterior pituitary is that of antidiuretic hormone. Antidiuretic hormone, also known as ADH, also known as vasopressin. Now, diuresis means to urinate or to relieve your body of fluid. Anti means to stop this. So, antidiuretic hormone stops your body from releasing fluid. This is important when we're dehydrated. So ADH or vasopressin is released in times of dehydration. Tells the kidneys to hold the water in the bloodstream, hold the water in the body. It also will increase blood volume and blood pressure at the same time. So we've gone through that. What about other tissues like the parathyroid gland? The parathyroid gland, which sits behind the thyroid, parathyroid gland, releases a hormone called parathyroid hormone. And what parathyroid hormone does is it increases the amount of calcium in the bloodstream. Interestingly, the thyroid releases another hormone which we didn't talk about called calcitonin, which does the opposite. It decreases the amount of calcium in the bloodstream. This is homeostasis. So if blood calcium's too low, parathyroid's released, it bumps it up. If blood calcium's too high, calcitonin's released, it drops it back down. This is that beautiful relationship of maintaining healthy physiological functions or homeostasis. Last one I want to talk about is that of the pancreas. The pancreas releases two very important hormones you need to be aware of. That includes insulin and glucagon. And again, similar to what we spoke about with calcitonin and parathyroid, they oppose each other. They do opposing functions. Insulin drops blood glucose levels. Glucagon increases blood glucose levels. So if you've just eaten a meal, for example, your blood glucose levels are going to go up. Well, insulin's then released from the pancreas, and it drops it back down because it tells the cells of our body to pull the glucose in and use it. If we haven't eaten for a number of hours, glucagon's released from the pancreas. It releases any stored glucose into the bloodstream so the cells can take it up, again, maintaining homeostasis. So what we've gone through here is an overview of some of the important glands and hormones of the endocrine system.